This video is going to be an intro to the E2 reaction. So here are the main parts of an E2 reaction. Just like an SN2 reaction, this reaction has two main steps that happen in a concerted manner, meaning they happen simultaneously at the same time. The E here just represents that it is an elimination reaction, and then the 2 means that it is bimolecular, meaning that the two steps happen in a concerted manner. And the two steps, like we talked about in the overview of E2 reactions, are a proton transfer and the loss of a leaving group. And also, the rate of this reaction is dependent on the substrate and the base. So here I've drawn out the basic E2 mechanism. So what happens with this is that a base is going to take up this beta hydrogen, and remember that the beta hydrogen is on the carbon over from the carbon of the leaving group. So here's the alpha carbon of the leaving group, this is the beta carbon, and then you have the beta hydrogen coming off of that carbon. So the base is going to take up that hydrogen, the hydrogen is going to donate its electrons back to the sigma bond, and because that sigma bond is becoming a pi bond, the leaving group doesn't need to be there anymore, and so it gets kicked out. And that leaves behind a double bond plus the leaving group. Now we're going to talk about the effect of substrate. For an SN2, a primary substrate was kinetically favored, meaning that if you had a leaving group as a primary substrate, that was favored because the nucleophile needed room to come in and attack the carbon. So for example, if we have, say this is the leaving group, and then so for an SN2 reaction, this is a primary substrate. It is on a carbon that has no other substituents coming off of it. This is favored. But for the E2 reaction, the reagent is a base, whereas for SN2, it was a nucleophile. So a base is going to act in a different way than a nucleophile. The base is going to extract a hydrogen atom, and it is not affected by steric hindrance. So for a nucleophile, I'm just going to put N for nucleophile, it needed lots of room to come in and attack this carbon, so that's why we didn't want a bunch of other stuff crowding this carbon. But like we saw in the mechanism for E2, the leaving group isn't really affected by, or the carbon of the leaving group is not really affected by steric hindrance because it takes away that beta hydrogen. So this means that actually a tertiary substrate is favored. And we see here that the slowest to fastest rate of reactivity for an E2 is going to be, here we have a primary substrate, here we have a secondary substrate, and then the fastest would be a tertiary substrate. This carbon has 3 other groups on it, making it tertiary. This one has 2 other groups, meaning it's secondary, and then this carbon right here only has 1 other thing on it. So for E2 reactions, the fastest is going to be a tertiary leaving group. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our Tutoring Center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.